When NASA launched the Hubble Space Telescope on April 24, 1990, aboard the Space Shuttle Discovery, it was heralded as a groundbreaking moment in astronomy. Orbiting above Earth's atmosphere, Hubble promised to deliver crystal-clear images of the universe and revolutionize our understanding of space. But within weeks, that dream turned into a public relations and scientific nightmare. Soon after deployment, NASA engineers noticed that the images sent back by Hubble were blurry and distorted. After extensive analysis, they discovered that the telescope's primary mirror, an essential 2.4-meter or 7.9-foot piece of precision glass, had been ground to the wrong shape. The mirror had a spherical aberration, being too flat at the edges by just 2.2 microns, about 1/50th the thickness of a human hair. This tiny error rendered Hubble unable to focus light properly, making it nearly useless for most of its intended scientific work. The flaw was traced back to a manufacturing error by Perkin-Elmer Corporation, the contractor responsible for polishing the mirror. During the testing process, a key optical testing device called the null corrector had been incorrectly assembled. This mistake went unnoticed due to poor oversight, overconfidence in the equipment, and a lack of redundant testing methods. As a result, the mirror was precisely ground to the wrong specifications. Rather than scrap the $1.5 billion telescope, NASA engineers devised an ingenious plan: build corrective optics that would compensate for the error, essentially giving Hubble a pair of glasses. This solution came in the form of the Corrective Optics Space Telescope Axial Replacement, or COSTAR. It was a refrigerator-sized instrument that would intercept the light from the flawed mirror and correct the distortion using tiny mirrors. In December 1993, NASA launched the Space Shuttle Endeavour on mission STS-61. Over 11 days, astronauts performed 5 spacewalks to install COSTAR and replace Hubble's Wide Field and Planetary Camera with a new version that had its own built-in corrective optics. The mission was a huge success. Once COSTAR and the upgraded camera were in place, Hubble began delivering the sharp, detailed images that had originally been promised. These included stunning views of nebulae, distant galaxies, and helped in determining the age and expansion rate of the universe. The successful repair of Hubble became one of NASA's greatest triumphs. It demonstrated the value of human spaceflight, engineering ingenuity, and perseverance in the face of failure. Over the next 2 decades, additional servicing missions upgraded Hubble's instruments and extended its life. Thanks to these efforts, Hubble has become one of the most productive scientific instruments in history, contributing to major discoveries like the accelerating expansion of the universe, leading to the Nobel Prize-winning discovery of dark energy, direct imaging of exoplanets, detailed views of stellar nurseries and the life cycles of stars, and improved measurements of the Hubble constant. What began as a catastrophic failure became a landmark success in space science and engineering. NASA's ability to recognize the problem, communicate it transparently, and deploy a complex and risky solution in orbit helped restore public confidence and cemented Hubble's place in scientific history. Now, even as the James Webb Space Telescope takes center stage, the legacy of Hubble and the people who saved it continues to inspire future generations.